All right, we're in grade 12, and in grade 12 we are going to be looking at proportions, and we are in part 1C, whereby we are going to be looking at exemplary questions. Now let's take a table. Let's take a table like this, and then let's say we have x, we have 0.5, okay, we have 1, we have 3, we have 4, we have 6. All right. Now somewhere here, let me just put 18. Okay, let's say the question says complete the table for each of the following statements. Complete the table for each of the following statement. Statement 1. Okay, y varies inversely as x. Y varies inversely as x. All right. Now you need to complete this table. Okay, you complete this table for this statement. Let's say this is the question that you have. All right, so how do you go about it? If they say complete the table, that means you are going to find the values of y here, the missing values of y when x is 0.5, y when x is 1, okay, yeah, y when x is 3 has been given for you, then y when x is 4, and the value of y when x equals to 6. That means before you can be able to find the y values here, you need to have the formula for y, the formula of sort of an equation for the y, where y is the subject. Okay, now we need to come back to the statement and try to analyze what it means. It says y varies inversely as x. So in our previous discussion, we did look at this. We said that this is very important here. We said this is very important here. This one. This we said this varies inversely. It's a key phrase here. So if it varies inversely, that means when y increases, x decreases. Okay, when y increases, x decreases. That's what it means. Or when y is decreasing, then x is increasing. Okay, inverse proportionality. That's what we discussed. Now, so we will write this statement symbolically. All right, so we are going to say y varies inversely. If it's inversely, then we are going to have the reciprocal of x here. Y varies inversely as x. Symbolically, it's written like this. Okay, we are not yet on the formula. We still have to convert this now into a formula. So this says y is equal to, okay, so we need to put k, okay, times what? K times this 1 over x. So that's how we once you put the equal sign, you must put k and multiply k by what is on the right of this symbol here. Okay, so that means y is equal to k over x. Okay, so let's make k the subject. Y is equal to k over x, and we want to make k the subject. All right, let's make k the subject, because if we want to find y in order to fill up this table, okay, that means we are given x but we don't know k. We are given x but we don't know k. So everywhere you come, whether here, you will be able to say y equals to k over 0.5. Are you aware? Y equals to k over 0.5. But unless you know the value of k, then you cannot find y. So it's wise for us to find k first. So that says we are going to make k the subject. Let's multiply by x. Let's multiply by x so that this cancels this. Okay, yes, so that we know what k is. All right, so now it looks like our k is equal to xy. Okay, now let's find k. How can we find k? We need to have a certain value of x with its corresponding value of y. So if you look at the table here, this is the case here. This part was given to you purposely. This part, they gave you a value of x with its corresponding value of y, so that they would enable you to find k. Now our k is equal to x times y. In that case, it's x times 18. 3 times 18. So 3 times 18 is actually it's 54. Okay, it's 54. So k is 54, and this k is very important. It's what we call the constant of proportionality. It's called the constant of proportionality. K is the constant of proportionality. So if we say it's the constant, that means k is the same everywhere. It's like you have a straight line, and then we talk of the gradient. When you talk of the gradient, we know that the gradient of a straight line is the same along that line. At any point on that same line, you will have the same gradient. So even in this case, when we talk of k, we are saying k is the constant of proportionality. What does that mean? That means k is the same everywhere. That means even here we have k as 54. Here we have k as 54. Here we have seen k is 54. Here k will be 54. Here k will be 54. All right? So that means now you can be able now to find y here, because y, it's here, y equals to k over x. Okay, therefore here when x equals to 0.5, what happens? Y will be equal to 54 divided by 0.5. We have substituted this. Okay, and this. All right, okay. Now then 54 divided by 0.5 is going to be how much? 108. Then y equals to 108. Okay, that means the value of y here will be 108. Okay, let's look at y when x is 1. When x equals to 1, okay, then y will be k over x. All right, which is what? Equals to k is a constant, it's the same everywhere. 54 divided by 1. Okay, so 54 divided by 1 is 54. All right, so when x equals to 1, k is going to be 54. All right, all right, all right. Now you are beginning to see this. This is easy. Okay, let's continue. Now let's say when x equals to 4, okay, when x is equal to 4, then y is equal to k over x. Then k is the same, is the constant, it's 54 even here, and then our x here is 4. So 54 divided by 4 is how much? 54 divided by 4 is how much? It's 13.5. That means when x equals to 4, k will be y will be 13.5. All right. Now we are left with this when x is 6. So when x equals to 6, all right, y will be equals to what? K over x. All right. So that is what? It's equal to k is the constant. It's 54 everywhere, divided by x, which is 6 this time. Okay. So 54 divided by 6 is how much? It's 9. It's equal to 9. So that means when x is 6, then y will be 9. Okay, that's how you fill this table according to this statement. Okay, let's recap. Even before we could fill up this table, we said that if it says varies inversely, that means when x increases, y decreases. Can you see that pattern here? Y was 108 at the beginning, but at the end is 9. That means y kept decreasing as x kept increasing. So because x and y are inversely proportional, when one increases, the other one decreases. That's the backbone of our concept here, or our approach. All right. Now, then you need to understand they are saying varies inversely. That's what will trigger your starting point. Like now we know that, okay, that means y varies inversely as x should be symbolically written this way. Now from here we need to have an equation. This is the equation here. This is the equation, and from this equation we must first of all find k. This is where we tried and found k here. This is where we found the formula for k here. But here, that is the formula for y. These two formulas are very important. You need to have the formula for you to find y. But because there is k, which is unknown, you need to find k first, this one, because you will be substituting it in here for every value of x. That's what we have been doing here, okay? And where? Here, all right? And here, and here, so that we could find the corresponding values of y. All right? Now, I think you are happy. I think you are happy. Okay, let's continue. Let's look at this again. Let's continue, because we still have to continue with this question. We were on part 1, so we will move on now to the next part. Okay, the next part of this question, we still have the same table. We still have the same table. Let me just increase my font here. And then we still have 0.5, 1, okay, 3, 4, 6. We still have 18 here. All right, but this part 2, it's saying y is directly proportional to the square of x. Y is directly proportional to the square of x. Y is directly proportional to the square of x. All right, so you complete this table according to this statement. So the key phrase here is directly proportional. All right, directly proportional. So now let me go for this one. Now, what does it mean? It means that y is directly proportional to x squared, the square of x. Directly proportional. So if it's directly proportional, we don't put 1 over. We don't put the reciprocal here. It's directly proportional. Okay? Now, what does this mean? This means that y is equal to kx squared. All right? Where does this k come from? Once you put an equal sign from this symbol, once you put an equal sign to have a formula here, you must always put k. All right? Now, this is the formula. If we are going to find y, we will always have to have k and multiply it by x squared. So this is the formula that we will be using to find the corresponding values of y. Now, we will have the x's because they are given here. There is no problem. But we don't have k. We don't know k here, which is the constant of proportionality. So first of all, we need to find this k here. Let's find the k there. Okay. Now, from this, if you want to find k, you will just divide by x squared. So k will be equal to y all over x squared. Okay. K is equal to y over x squared. All right. This is very important. Now let's find this k. Let's find this k. Let's find the k. Okay. Let's find this k. Let's find this k. So this k is equal to what? Y, the corresponding value of x, and y. We can use the given ones. They've given us this pair, this one here. This part here is very important. So y is 18, and then x is 3, so we are going to square it. 3 squared. Okay? Now, that means we have 18 over 9, which is 2. So k is 2. K equals to 2. All right? So once we have the value of k here, okay, we can easily find, once we have the value of k here, we can easily find this value here is very important. With it, we can easily find the y's. Okay. Now let's see. When x equals to 0.5, what will be y? Y is equal to kx squared. See here. Okay. So we know k is the same everywhere. It's a constant of proportionality. So it will still be 2 here. 2 times what? 0.5 squared. Okay. So 0 times 0.5 squared will be it will be 0.25, right? 0.125. 0.125. We multiply that by 2. Okay? It's 0.25, okay? 0.25 multiplied by 2. We get 0.5. Let me see. Let me just confirm this. It's 2 times 1 over 2. 0.5 is 1 over 2 squared. So it's the same as 2 times 1 over 4 again. So this goes once here and twice here. So we have 1 over 2, which is 0.5. Yeah, it's correct. All right? This is correct. Now, okay, I was just trying to confirm here. This is correct. Now, y will be 0.5. Y will be 0.5. Okay. Okay, when x is equal to 1, what will be y? Y will be kx squared, which is 2 times 1 squared, which is 2. So y will be 2 here. Okay? Now, when x equals to 4, then y will be equals to kx squared, which is 2 times 4 squared, right? Which is going to be 2 times 16, because 4 squared is 4 times 4, which is 16, times 2 equals to 32. Now, y will be 32 here, all right? So when x equals to 6, our y will be equal to kx squared. And then this kx squared will be 2 is to 6 squared. That is 2 times 36. 2 times 36 is 72. All right? So that means here y will be 72. Okay? So let's recap. It's not difficult. It's not difficult indeed. All you have to do is you need to understand the procedure. Where do I start? Okay? Where do I start? Then what do I want? What do I need? This I need. But before being able to use this one, I need to find this value of k, the constant of proportionality, because I'm going to be using it everywhere. Okay? Everywhere. Okay? Now, that is basically what you need to do. So let me give you an assignment here. Do this on your own. Okay? Do this on your own. Complete that table. Okay? Complete that table, all right, for this statement. Y varies as 1 over x squared. Y varies as 1 over x squared. Can you complete the table, the same table? All right, the same table. Complete the same table using this statement. All right? Okay. Till we meet again in our next presentation. Take care.